We're all here today because of the hard work of Wisconsin dairy cows, whose milk supports an internationally competitive dairy industry and the employment of more than 100,000 Wisconsinites. More to the point, the cheese is excellent. Unfortunately, cows produce more than just milk. One example is methane, a greenhouse gas about 30 times more powerful than carbon dioxide that cows are constantly burping out. To complicate things, dairy system emissions are coming from more than just cows themselves. One thing that cows produce more than anything of is manure, which during storage also produces large amounts of methane and when applied to land can lead to emissions of nitrous oxide, a greenhouse gas even more powerful than methane. Fortunately, we do have some strategies for trying to mitigate these greenhouse gas emissions at the various stages. For example, researchers at UW-Madison and elsewhere have observed that feeding cows a diet high in starch actually decreases methane production while increasing milk production per unit of feed. However, cows, manure, and soil are not really independent systems, and we cannot manage them as if they were. Manure chemistry depends very heavily on the type of feed cows are eating, and soil processes after manure spreading, in turn, depend on manure chemistry. Thus, when we're seeking to determine the impact of diet on greenhouse gas emissions from dairy systems, we have to look not just at cows, but also at manure and soil. And that is just what I sought to do. So as part of an interdisciplinary team aiming to improve dairy system sustainability, I conducted an experiment to determine the impact of dietary starch on greenhouse gas emissions from manure storage and following soil application. To do this, 64 cows at the Arlington Agricultural Research Station were fed diets of either high starch or low starch for 5 weeks. And at the end of those 5 weeks, I collected manure from those cows and measured emissions over months of storage. After several months of storage, I applied the manure to soil in the lab and measured emissions over 1 month in the lab. And I found some pretty interesting results, both in manure storage and coming from soil. So in the manure storage, manure from cows that had been fed the high-starch diet actually produced 33% more methane than manure from cows that had been fed the low-starch diet. Conversely, manure from high-starch diet led to a 56% reduction in nitrous oxide emissions coming from soil. But because there was so much more methane coming from manure storage than from soil, the overall downstream impact was an increase in greenhouse gas emissions. This is particularly interesting because it's in opposition to the established impact of high-starch diets, which is a reduction in enteric methane coming from cows. So the next step would be to compare the benefits at the cow level with the benefits we observe downstream. Thank you.